So we're talking about active matter at this point, and we have one little piece of unfinished business on the subject of Chara. And this is a quite beautiful paper from Francis Woodhouse and Ray Goldstein that I wanted to tell you a little bit about. So, I've tried to make the distinction over the term between knowing and knowing about, and I find that to be a very useful distinction. And I think that one can think creatively with either knowing or knowing about. Knowing about at times serves as a foundation upon which to build things, even though you may not have mastery of the underlying things. It might just sort of click in one's mind that, oh, there's this connection that I hadn't appreciated before. So the goal of this paper, was we earlier already talked about the flows within Chara, and I gave a superficial analysis of, how those flows are created by these boundary conditions. Let's see here. So you can see on the right-hand side, these are the boundary conditions. And what I want to do now is I want to talk about the emergence of the order, the actin and myosin, that gives rise to those flows. And the question being posed here is whether or not this arrangement of actin and myosin 2 is some myosin. Sorry, I was thinking about the tissue morphogenesis problem. Whether the myosin and actin sort of dance is spontaneous. You'll recall back to when we talked about positional information and we talked about Turing. This is kind of in the same spirit of all of that. And what I mean by that is that here the question they posed is whether or not the coupling between fluid flow and local alignment could have actually led to an instability that led to order. And so let me try to give you a sense of that. What I like about this is that what we're doing now is we're augmenting the hydrodynamic description of the U field, which is basically given by the Stokes equation, and we're generalizing it. And maybe the way I can say that is that you'll recall from earlier that we had the Stokes equation, which maybe I can come up here and copy and bring downstairs. So we had this equation. Here's our Stokes equation. And now instead of on the right-hand side, instead of having 0, this is going to be the forcing due to the alignment. So check it out. What we're going to do is we're going to introduce a new field variable. And actually, forget the bottom example. So we're going to introduce a new field variable, P, which is the polarity, the filament polarity. It tells us about the local orientation of the actin filaments. And the beauty here is that P drives U. In other words, the current orientation of the filaments is the current direction of motion of the motors. That entrains the fluid, and so that drives U. But the U, as you see at the bottom, it actually aligns, here the U aligns P. So the P field is moved by U, and so there's this interplay between those two. And so I'm not gonna go into the full description, but what I'm claiming is that previously we had two PDEs. We had the Stokes equation and the continuity equation. Now to that we will add a third equation, which is shown here. So here is this is the paper of Woodhouse and Goldstein, and this equation that you see here is the equation for the P field, and you see just below it the equation, Stokes equation, but now with the right hand side that this is the driving force. So that's the coupling between U and P. Note, the U field described by Stokes, it's coupled to P through the P on the right hand side. Note that in the P field equation there is in the P field equation there's U. Here's a U right here in the star equation. My mouse is not permitting me to circle it, but I hope you can see in the equation that I've annotated with star. Let me just give you an aside. David Mermin is very strong on this point. I 100% agree with him. Every single equation in every paper, every book should be numbered. Period. Non-negotiable. Just for all time. It's surprising to me and disappointing that Ray Goldstein didn't insist on that with this PNAS paper. Anyway, so back to this thing. So there's this P field equation. This is basically just trying to tell you the nature of the terms that are engaged, and I'm going to focus on this one. So this is basically telling you that the P field aligns with the U field. There's some obscure notation here, which I think, in the interest of time, I'm not going to explain to you, but this thing is a projection operator. What it does is it basically takes the P and it projects out the part that's parallel to U and leaves behind the part that's perpendicular. And at any rate, the main point is that that these different terms, each one of these terms, is a physical effect, a coupling between U and P, and there's many of them. So as you see on the bottom, the filament avoids curvature. So that is to say that the filaments don't want to be on the most curvy part of the cylinder of Chara. They would like to be pointing in the vertical directions. There's a term that represents that. Number 3, the flow aligns the filaments. That's a very important term, and one can make toy models and understand how that works. Then there's diffusion of polarity. The flow advects the filaments. So each one of these is a different term in the PDE that I showed you, and I just want to conclude by showing you this, which is that what they do is they start with a random orientation field, and they see that spontaneously this thing organizes so that you have part of the flow going up, which is shown here in purple, and then part of it going down, or I can't see well enough to tell, but I think the green is going down. And there were some experiments done where they basically poisoned, if I remember, the actin, and then once the drug is taken away, the structure reemerges. That's really strong and compelling evidence for this kind of mechanism, a mechanism like this. I'm not saying this particular set of PEs. And the zone of indifference, the interface between the up and the down region, moves. So there's not like a pre-existing structure inside of the cells that then spontaneously starts turning on again once the actin is turned back on. So this was just a little vignette aimed. Really, it's kind of a cultural tour, and intentionally superficial, a little bit sloppy. There's a lot to think about here. Just even understanding these projection operators is subtle. This thing, and why one has it. What I'll tell you, maybe I'll just write this down, is that the definition of P outer product P. I don't know what's going on. This thing is being really slow. Okay, it's not reacting in real time, so I think I'm not going to attempt to write things. Let me try one last time. If it doesn't work, I'm abandoning. Okay, yeah, it's something is not right, so I'm going to leave it at that.